All right, here we get started with our Algebra 1B notebook for this semester. Today we're really just going to be looking at some review topics. So we're going to be looking at different functions and some line stuff. So what you need out of that packet that I gave you is, first of all, you'll need your notebook. You will need one page that looks like this, and it is white in your packet as well. You'll need one of these vocab sheets, and we're going to be using these a lot, so you'll get really good at using these, and we'll use a lot of them. You will need one that looks kind of like this. Yours is not white though. The ones I printed for myself are white. And you will need this one. These are the four that we're going to walk through here today. And so first we're going to actually be looking at our vocab word and our definitions. So the definition and the vocab word that we're really going to be looking at here is a function. So we're always going to write our vocab word right in the middle in that oval circle. So that's kind of where we're going to start. Then of course we're going to come up with some definitions. You and I together are going to come up with definitions and some characteristics. And then on your own, that I'm really going to be checking when we get back in class, are these two down at the bottom. Can you come up with an example or two? Generally I'm looking for 2 or 3 examples, and then 2 or 3 non-examples. So these are things that do not fall into what a function actually is or what it looks like. So really the first definition, we want to come up with our own definitions for these words and not use the big fancy ones. So our real definition of a function is going to be an equation, and I like to abbreviate my notes as well, where each input has exactly one, and I'm going to underline because that's the important part of a function, output. Okay? So I have an equation, or I have, I have my equation where each input, when I put in a number in or a value in, I have exactly one output. So what does this kind of look like? One thing we see is we have the vertical line test. So the vertical line test tells me that if I've got my equation, if I've got it graphed, so for an example, we're going to look at this parabola. So here I see that if I used a vertical line, and I'm going to use this one as pink, so sometimes colors come in handy. If I draw a vertical line through this function right here, I touch the function in more than one place. So this is not a function. So when I pass the vertical line test, that means I touched the equation in only one place. So that's one characteristic of a function. Well, what if I'm not given the graph? What if I'm given like a table, for example? So let's look at the table for here. So I've got some x values and some y values. So what I really want to look at is, when I'm looking at my x values, if I have different x values, that really helps me. So different x values, that's a function. And I abbreviate function as fxn. That's just how I can recognize it and see it. Okay. So if I was to have something of like this, if I had 2 1s and a 3 and a 2 here, we see that my input here is 1, but I put that in and I get 2 different things. So this example right here would not be a function. Okay, so those are some of our big characteristics of what we can see if we're given kind of a graph, if we're given a table. You often will also be given an equation, and that can be determined as, do you get one answer back or do you get more than one? So now you are going to go ahead and come up with an example and a non-example. And let me show you what this is going to look like in our notebook. Okay, so since we're starting here, we don't really have lots of learning targets for today, so we're just going to start with our notebook. This first page, I want you to decorate somehow. This is how you're going to make it personal. This can be your doodle page throughout the semester, something like that. So then on this next page, this is where this function word is going to go. And if you're like me, I didn't cut these down yet. The next ones we get will be smaller. So we can fold it in a little bit on each side. And then you're going to glue this into your notebook so that it stays there, so we have this example every time we need to deal with a function. So next week when we have class, I am going to be checking on these. Did you come up with your examples and your non-examples? If you get stuck on that, just let me know. So the next thing we're going to be looking at is, okay, so what does it look like if I'm dealing with an equation? So this is the page that you're going to need right now. And right now, you need to go ahead and cut out around this solid line, this big solid line, and cut out around this piece. So go ahead and do that right now. So now you should have something that looks sort of like this. Then on this piece, we are going to go ahead and cut along the top and bottom of both of these pieces, because you'll see that this little piece slides in from the bottom through the top, and this also slides in the bottom from the bottom to the top. So what we're really looking at is people get very confused at function notation. Now, function notation doesn't actually tell us anything different or new. So we're going to go ahead and place this little creation. Go ahead and pause the video if you need to the side, and then we're going to talk real briefly about function notation. Okay? So in your notebook, on the next page, after you've folded and glued your function words, your definition in there, we're going to go ahead and look at function notation. So function notation, and you're going to see this all the time this semester and in future math classes. This is where I have this looks like this. This tells me f of x. That's how we read this. So this is f of x. So all this tells me is that this is the function output. Okay? So that's the important part, is this is the output. The other output that we have looked at often is y, right? In a linear equation, right, if I had that y equals mx plus b, we've looked at that before. Our input, we would always input different values of x and come up with an output of y. But it was not always necessarily a function, looking back on what a function actually is and the characteristics. So now we're dealing with just functions. So this tells me that this is a function and my output is this whole thing, right? That's the output. The input is my x still. That's the different values I can put in for x. You'll also notice that this may be a different letter. So I have to use f and g, and that just tells us they're two different functions. So f labels like the blue one, and g would be like the green one. It just tells us they're different functions. So now let's look at how we can see that and how we use that. So we're really going to be using this function notation slider to help us get there. So what you need to go ahead and do is we're going to be gluing on the very top of these two pieces and on the bottom here. So I'm going to go ahead and do that so that mine sticks in my notebook. So go ahead and glue the very bottom piece and then the tops of both little legs. And it can go in right here. Okay, so you see that this piece, this slides up and down so that we can use different examples. Okay, and I went ahead and I used a linear example. So this just tells me, and I'm going to use a different marker here, that if I have f of x equals 3x plus 4, that's generally what we'll start seeing, is some f of x equals an equation. It won't always be linear, but that's where we're going to start. So you may be asked to find f of 4. So what that really means is if I slide this down, I would take f of 4, and that just means I plug in anywhere I see an x in my equation, I go ahead and I solve it. So what that really turns it into is I now have 3 times 4, because I always want to multiply first, which means I have 12 plus 4, which equals 16. So that's how I would evaluate using my function notation. So let's go ahead and try another one. So now if I have f of 7, that also means I put in a 7 anywhere I see that x in my equation. So that gives me 3 times 7 is 21 plus 4, which equals 25. So that's how I would evaluate using function notation. So now you have a couple more examples, and I want you to keep this slider and go and create a couple more examples so that you get the hang of what this really means. So then if I gave you this same equation, so we have f of x equals 3x plus 4. That's what we're looking at here. So now I'm going to say find, right? That's generally our term of like, what are we doing? Find f of 13. What does that mean? How can you use this, what we just figured out, to plug in this information and solve that and find that for me? If you email me this answer, what you get from evaluating at f of 13, you'll get a little prize next time I see you on campus. Okay, so go ahead and fill these chunks out so that you can get the hang of it and keep going with that. So the next thing we're going to look at is you are going to have to take the information that we've learned and looked at so far and kind of do some sorting. So the next thing we're going to need is this sheet right here. So the first thing you need to go ahead and do is cut on all the dotted lines. Just cut on the dotted lines. And I'm not going to do this because this is kind of an activity for you to do. So then open up your notebook and you're going to want 2 pages that face each other. Okay? So here are my 2 pages. On one page, you're going to glue this function, and on the other page, you're going to glue this not a function. So then what you're going to do is all of these different relations, you are going to place them in the appropriate location. Is it a function? Is it not a function? The other thing that you must do to get credit for this page of your notes is I want to see why it's a function or why it's not a function. So you can highlight, circle, use arrows, but you're going to be taking all of these little pieces once you cut out along the dotted lines and sorting them. Function or not a function, and then give me a justification. So I'll go ahead and look at this first one for you. Okay, and we can justify it as well. So we've cut out function and not a function. Let's look at this. So here I see I have x values of -2, 1, -1, -2, and -3. Well, I notice I have 2 of the same. So these x values were the same. So that tells me I then have to look at the y value. In this case, the y value is the same too. That tells me every time I plug in a -2, I'm going to get the same thing back out, which tells me that yes, it is a function. So I would go ahead and put that on my function page underneath this function heading, and right on the side I would say each x value has only one y value, because that's how I know for sure that it is a function. So go ahead and do this. This I'm going to check next time I see you in class. Because don't forget that we are going to be getting some points for our notebooks, and this is really our learning that we're going to be doing this semester. Okay? So then finally, for today, you're going to need this slope sheet. That's kind of the last thing we're doing. So we're going to fold that over. And for me, I really want this to fit on my notebook page. So I am going to cut around the edges, and I will do this in the future, but that doesn't help you guys. So we're going to cut around and make sure that it will actually kind of fit on the page that I have. So not only am I going to cut around the edges, I'm also going to cut on anywhere you see a dotted line. You're going to go ahead and cut on that spot as well, because that's going to be what we're going to fold up and write some stuff underneath. Okay, so there we go. I've cut off my edges, so now I see that it definitely will kind of fit on my page. So now I'm going to go ahead and cut along all of my dotted lines. So now that you've got all these dotted lines cut, now we're going to glue this or tape this down. So make sure you only glue or tape kind of on the big spots for now, not on anything that we're going to fold. So the bottom here, don't forget the middle of the bottom is also folded up. So we're just going to do some glue right up here. And then find a great space on your notebook. So we're really going to just be reviewing slope. You should remember a lot about slope, but we're going to get some specifics down here. So I want you to come up with one definition of slope. So what is one definition of slope? We've seen a lot of slope, definition of slope be rise over run. Well, that's kind of one way to find it. The other big thing and how we really want to think about slope is it's the steepness of the line. Okay, so that's going to kind of be our working definition, is the steepness of our line. Okay, what are some methods we can use to determine the slope? Well, we said this in our definition. We can look at the graph and do rise over run. And we can determine, as I'm reading from left to right, is it positive or negative? So I'm going to say left to right, plus or minus. That's how we can determine it. Am I looking at positive slope or negative slope? So what's the slope formula? How do I find slope if I'm given just my points or just my equation? Okay, so to find the slope from our 2 points, it's y2 minus y1 over x2 minus x1. Because my y's, remember, is the rise, and my x's are the run. X1. So rise over run. Or we can also see it as delta y, just means the change in y, over delta x. Okay? So here, underneath this one, you're going to go ahead and do this one yourself. And I want to see what you come up with if you can find the slope between these 2 points. Let's continue over on this right side. So a positive slope. So the easiest thing to remember is when we're reading, right, I'm going to draw a little coordinate plane. As I'm reading from left to right, I'm dealing with a positive slope, which means it goes up as I go from left to right. So then again, a negative slope, again my coordinate plane, as I go from left to right, just like I would read, it would go down. So what if I have a 0 slope? What does that mean? So going back to our definition of what slope is based on the steepness, if you have no steepness, if that is that easy of a walk to do, and I have 0 steepness, it's going to look straight across, just like that. So then down here, an undefined. Well, I know I don't have any going up, and I already have one going down, and I already have one going across. So all that really leads is going straight up and down. And we think of this as undefined because there's no way that you could actually walk on that steepness of a hill. Okay, so now it's your turn to kind of try a couple of things as a review. All right, so we're going to determine the slope from these 2 points. I want you to also determine the slope from this graph, and I want you to determine the slope from this table. So those are going to be really the things I check in this notebook for you. Okay, so this whole kind of what we just looked at today was meant to be a review as we take this information and kind of dive into a little bit more and dig a little bit deeper into it. So now that we've got this, you can spend a little time and color and make these notes yours, because this is going to be a resource that we use over and over and over again, and we use it very often. Okay? So don't forget that if you get stuck or if you need help with any of these things that I've asked you to do on your own, please contact me and let me know, and I can help walk you through it, or we can sit down and do it together.